It's 2:13 on a Tuesday. Elevators stall between floors, a hallway goes dark, card readers stop accepting badges, and the call center lights up. One automatic transfer switch failed to call the generator. Tenants feel heat and lost access within minutes. What else failed with that switch?
Welcome to Built, Wired, and Secured. I'm Alex Morgan. Today, how to build an operational dependency map so you know what actually breaks and who needs to act when a system goes down. Michael, James, great to have you both. Michael, that opening, what's your immediate reaction?
Thanks, Alex. My first thought is always the same. What breaks if this goes down? If you can't answer that in the first 10 minutes, you're responding blind and wasting time.
Right. Reliability starts with disciplined maintenance, yes. But you can't prioritize maintenance unless you know dependencies. A map tells you where preventative work actually reduces tenant impact and where it only gives you paperwork.
So when we say map, what belongs on that page? Power, sure. But beyond that, what do you insist on including?
Start with the physical flows, main feeds, automatic transfer switches, generator logic. Layer in UPS zones that protect specific systems, then network paths, both on-site switches and carrier circuits, then control systems, BAS, access control, fire panels.
Hold up. When you say UPS zones, do you mean per floor UPS or per system?
Both, actually. Show the system-level view so a facilities manager sees HVAC pumps, and also the zone-level feeds, so an operator can trace pump A back to its UPS and ATS. You need both perspectives to trace impact quickly.
And don't forget the small physical gotchas. Locked panels, breakers labeled poorly, vendor-supplied controllers that sit behind a contractor's lock. Those are the things you need in annotations so an on-site tech isn't surprised when they can't physically switch anything.
Good. Layers and annotations. How granular should the shared map be, though? Too much detail and it becomes unusable. Too little and it misleads people.
Use tiers, a high-level diagram for stakeholders, a mid-level map for operations, and a restricted technical annex with sensitive details. And call out assumptions explicitly, like this BAS depends on outbound cloud off, because callbacks are a common blind spot.
Let's dig into those blind spots. James, what do teams usually leave off the map that comes back to bite them?
Shared infrastructure is huge. Systems that look redundant often share upstream wiring or control. 2 controllers, 1 upstream breaker. People assume failsafe, but that breaker is the real single point of failure. And then there are cloud callbacks, devices that only work when they can reach vendor services.
So a generator test could reveal multiple hidden dependencies if that generator doesn't behave the way every system expects.
Exactly. And another repeat offender is maintenance-driven change. Contractors adjust firewall rules, swap routers, or replace UPS hardware and forget to communicate the downstream effects. Suddenly, alarms are silent or cloud archiving stops, and the team spends hours chasing the wrong problem.
Been there. We had a router swap that killed outbound NAT for camera archiving, and because the map didn't call out that cloud callback, people tore apart racks before checking the ACLs.
That's a governance issue as much as a technical one. Ownership is where these things either get fixed or keep recurring. Who should own the map?
I'm not sure I buy facilities as the default owner. Facilities are often buried under projects and may not have the bandwidth to maintain it properly.
Fair point. But being swamped isn't an excuse for ownerless systems. Pick a single accountable owner, often operations or facilities, and give IT a co-owner role. The owner coordinates, convenes sign-offs, and enforces a quarterly validation. Without that, the map decays rapidly.
I agree with a single owner as coordinator, not gatekeeper. Make updates light, short changelog entries, and a quick validation call. That reduces friction and keeps the map current through vendor churn and capital projects.
You two make a good team. Coordinator plus SMEs. Walk me through a concrete incident that shows this failing in practice. Michael, you mentioned a UPS swap earlier. What happened?
A client swapped a UPS bank off hours. Mechanically, it was fine, but the new UPS had a different transfer profile. The generator didn't trigger the BAS the way the old UPS did, so critical pumps stayed off and tenants lost HVAC. No one had documented the BAS's dependency on that UPS transfer behavior. A quick test during the swap would have revealed the mismatch.
So the hardware swap looked like success on paper, but the behavioral nuance, transfer timing, was the hidden dependency. James, your router story?
On a campus, a vendor replaced an edge router, and the new config blocked outbound NAT for camera archiving. Cameras kept recording locally, but cloud archiving stopped. Because the dependency map didn't show that cloud callback, the team assumed local failures and spent hours troubleshooting racks. If the map had listed the callback and the owner had been informed of the router swap, it would have been fixed in 20 minutes instead of 3 hours.
Those examples show why the map has to be a living tool, used in tests and vendor meetings, not filed away. So 3 concrete steps listeners can take in the next 30 to 90 days.
Step 1. Inventory critical systems and single points of failure. Don't chase perfection. Start with the things tenants notice when they fail. Step 2. Draw a tiered map showing power, network, control systems, and any external cloud callbacks. Step 3. Assign a single accountable owner, set a quarterly validation cadence, and require a short changelog entry for every infrastructure change.
Bonus step. Use it in your next test. Make one map update and run it during your next scheduled generator or maintenance test within 30 days. That drill will expose mismatches and make the map worth maintaining. Preventative maintenance beats emergency repairs every time.
Quick security note. If you're worried about sensitive detail, keep the shared map high level and store breaker labels, port numbers, and credentials in a restricted annex. That way operations get the usefulness without exposing attackable detail.
Curious. Also, use the map to drive capital decisions. If one controller affects 5 tenants, it should be higher on the redundancy and testing list. The map helps prioritize spend where it prevents the most tenant disruption.
And bring a one-page diagram to tenant meetings. It saves time and reduces calls because tenants can visually see what systems are tied together. Fewer surprises, fewer angry emails.
Solid. If you take away one thing, inventory the critical systems, map the core dependencies, assign one owner, and run the map during a test within 30 days. Michael, James, thanks for sharpening the advice and giving such concrete examples.